electrostatic potential energy as well as potential. So basically we'll be dealing with potential energy difference first, and then we'll go for absolute potential energy, and then consequently we'll look after potential. So we'll take care of both qualitative as well as quantitative definitions as in every case. So qualitatively, what we define as potential is that it's a work done in bringing in charge from a finite or infinite distance. Let me say the point is A to another point, say B, in the vicinity of the second charge. So this means that we have two charges. We are bringing one charge from a point A to B, and there is a work done in both, and that work done is nothing but potential energy. Now that point A where we are bringing the charge maybe at a finite distance or maybe at an infinite distance. So depending on finite or infinite distance, we take it as like potential energy difference or absolute potential energy at a particular point. So okay. So to have a quantitative definition on this part, we go back to figure number 1. This particular figure. We see that capital Q is the charge and small q is the charge, two charges as say. Small q charge is at point A. Maybe finite or maybe infinite, and we are bringing the charge A to final point B, and we see that from the second charge capital Q, that A point is at a distance R and the B point is at a distance R. Okay. So we are bringing the charge small q from the point A to B. The final destination is B, and it is in the vicinity of the charge capital Q. So going back to the definition. So this is what we talk about from the diagram. So the work done will be now there's a force dot displacement. So it will be this one. Work done will be F ext dot 0. But before, what is F is an external force. Since we are moving a charge from a distance to another distance, or from one point to another point, so definitely there must be some kind of force involvement. And that force must be opposite to the Coulombic force. Since you know the Coulombic force is Q into capital E electric field, and so minus sign represents that the external force is opposite to the Coulombic force. So we are applying external force, and there is a displacement of the charge small q from a point A. And if the displacement is dr, this is dr. So the work done will be force dot displacement F dot dr. So this is the work done for a small displacement dr. From point A, there is a small displacement dr. Now, if we bring the charge capital Q from the point A to final destination, say point B, which is at a distance smaller as shown in the diagram. Let's again go back to the diagram here. You'll see that there is a small displacement, the work done was dw. And now from the point A, the final destination is B now. So what to do now? The way is that we have to integrate the expression dw. This was dw, and we'll integrate the expression to find the total work done for the displacement from point A to point B. So this is dw and A to B minus q as a c and f equal to derivative of Coulombic force. And then since E and dr are opposite, it means they are the same angle is 0 degree. So ultimately that is electric equation number 1. Now the electric field E is of the charge, second charge, into whose vicinity the small charge Q is, small q charge is brought. So this electric field is due to point Q, and at the point B, the electric field is equal to this, the very definition, capital Q by R square. So remember that we are taking the electric field of the second charge, and we are bringing another charge small q from a certain point A to point B. So this is equation number 2. This is well defined. This is the very basic definition of electric field. So using 2 equation 1, and since A is representing simply a distance at point A, and B representing distance at B, as in the figure 1. So this A is actually nothing is RA. and this B is nothing, its distance r. So doing the integration, we can find that W will be equal to the relation of the addition given as capital Q small q divided by 4 pi epsilon naught. And we get 1 by r minus 1 by ra. So 1 by r, this r is the distance of the point B, and this r is the distance of the point A from the second source capital Q. And remember that the capital Q is the source whose electric field we are taking care of. So equation 3 is nothing but it's simply the work done, and since the work done is, since it's a work done, so it's definitely the electric potential energy. So electric potential energy, since the point R, point A is taken to a finite distance, that's why this R is a finite quantity. And in that sense, that this 1 by R is representing potential energy at point B, that's UB, and this 1 by R into this quantity represents the potential energy at point A. So this, taking this common factor and considering the first term, this is representing, multiply this common term, this 1 by R representing potential energy at point B, and this 1 by R is, with this multiplication of this quantity represents potential energy at point A. So with the final, two finite points B and A, with A at a finite distance, we have these expressions. So this expression W equal to UB minus U represents electric potential energy difference between the points B and A. Suppose now the point A is at infinity, that means R is infinity, and if R is infinity, then definitely 1 by infinity is 0, so that particular expression will become this. Now this equation 4 represents the absolute potential energy at point B. So just to say the initial part of this video, that we have two kinds of potential energy we take care of. One is potential energy difference when that point A is at a finite distance, and another point, and in another case the point A will be at an infinite distance. So first case, the point A was at a finite distance R. In that case, we have this potential energy difference W equal to UB minus U, and in the case of R at infinity, this is given by equation 4. So this is representing absolute potential energy as given by W equal to U equal to UB, U capital U small q 4 by 4 1 by R. So basic thing is that potential energy represents the work done in bringing a source from a finite point or maybe infinite point. If it is bringing you from finite point, then we talk about electric potential energy difference. If we are bringing from an infinite point at an infinite distance, we talk about absolute potential energy, just like case of equation 4. So we have two expressions. One is W equal to UB minus UL, and one is W equal to U equal to UB, the absolute potential at the particular point B. And we also remember that the electric field we are taking care of is the second source into this, the source into the vicinity of which the test source, as we said, a small q as a test source, the test source is brought in. So let's now go back to what is electric potential. The same concept will be applicable here also. Only thing is that we replace that particular source which we moved, that let me say that this source as I represent as this source, that small q is equal to simply of +1, magnitude is +1. That means that the source we are bringing from finite distance to infinite distance is simply into positive size. So the thing will be same. Only thing is that if you remember that it is UA minus UB equal to capital Q into small q, 4 pi epsilon naught, 1 by r minus 1 by r. Here this q is equal to 1. So ultimately that UB minus U will now become VB minus VA. So that UV is now turning into VB, and that UA is now turning into VA. And as we see that this VB is representing the potential at point B, and VA is representing potential at point. So all the difference between potential energy and potential is that we multiply with the source. We multiply the potential with the source, then we get back the potential energy. If you put that particular source equal to 1 plus 1, then that potential energy becomes potential. That's the thing. And similarly, the absolute potential will be this. Just put q equal to small q equal to +1 again in that expression. That particular expression. 4. This is this expression, particular expression. Or let me then just take the small q equal to +1, and in that sense, this u will become v. equal to VB, and it's absolute potential energy. So to conclude that electric potential energy is simply the work done in linear charge, maybe at a finite distance or maybe infinite distance. If it is a finite distance, then we talk about electric potential energy difference. And if it is at infinite distance, we talk about absolute potential energy. And remember that we are bringing the charge into vicinity of second charge, and the potential is calculated in potential energy is calculated in terms of the electric field due to the second charge. Here the second charge was capital Q, as seen in the diagram. And the electric field were taking care of this because of this capital Q. And that point A was initially at distance R, it is brought to the point B, which is at the distance R. So coming back to potential, that potential is nothing, it's simply the potential energy. To just replace that charge, the test charge, which we have brought from infinity or from a finite distance, equal to simply plus 1. The unit magnitude, that is, let us take it as a positive charge. And everything will change, only U will become V, UV will become UV, UV will become VB, UA will become VA, and then U will become V for this particular condition P. So potential and potential energy is same thing, only thing is that the test charge is of unit magnitude, positive charge and a unit of unit magnitudes. So finally, this assessments, what is electrostatic potential energy, that's the definition work done, and then the difference between potential energy, difference in absolute potential energy. Just we talked about finite distance points. If the initial point is at infinity, automatically it becomes potential energy. Then an expression that we have derived here, and again the relation between potential energy and potential energy and potential relation is there. U equal to V into Q, V into small. That's the relation. So with these things that while winding up this video, I hope that you enjoyed the video. Thanks for watching. Bye.